So there's a lot of applications for fuel cells, obviously. One, of course, is cars, but you don't see fuel cell cars driving along like you do hybrid cars because the fuel cells are still in really the development phase. It's expensive. Um, it's just expensive to make the fuel cell. The parts of the fuel cell are expensive, and getting the fuel itself, just the source of the fuel, is still very expensive. And we'll look in more details at that. For example, let me tell you also that fuel cells are not just used in cars. There's also stationary uses, such as for producing electricity on site at a home or business, or used to generate electricity for batteries, like for computers and whatnot. So there would be a smaller or a larger fuel cell depending on how much power you need to produce. All right, so why is it a problem? Well, carrying around hydrogen is a problem because it's explosive. Again, if you have an accident where you have the hydrogen exposed to the oxygen quickly and there's a spark, it can cause a massive explosion, much bigger than a natural gas explosion, because there's more energy produced per gram of hydrogen burned compared to natural gas. So natural gas, if there's a natural gas leak, it can be dangerous, because if there's a spark and the natural gas concentration is high enough, there'll be an explosion. But hydrogen, it's much worse. It's like 3 times worse. So to get around that, because the fuel cells are a clean way an efficient way of producing electrical energy, another way around it is to carry methanol, say, in your car and reform it to hydrogen just before it is pumped into the fuel cell. So you store it as methanol in the form of methanol, and then you go through this reforming process to produce the hydrogen just on an as-needed basis, and then it is cycled into the fuel cell. Here's just an example of a reformer where you'd have the methanol fuel tank. So instead of carrying a tank of hydrogen gas, you'd carry a tank of methanol, and then you would heat it in the presence of water, and then you need a catalyst present, and then you would clean it up a bit, and then at the end you would produce hydrogen and carbon dioxide. Okay, so the overall reaction is from methanol to hydrogen plus carbon dioxide through this process. And so this is one way to produce hydrogen gas on demand for fuel cells. But can you see the problem here? The problem is you've got to get the methanol from somewhere, and usually methanol comes from natural gas that's been reformulated into methanol at some other location, and then you're still producing carbon dioxide, which is a greenhouse gas. So the whole point of alternative fuels is to limit pollution and greenhouse gases. This is a cleaner burn. We don't expect to be producing carbon monoxide because we're cleaning it up here and going through the catalytic process to get rid of the carbon monoxide, but still it's still producing carbon dioxide, which we know is a greenhouse gas. Okay, so there's workarounds to try to produce the hydrogen in the form of methanol. And in these cars, right now, the car technology with the fuel cell cars, normally they use methanol, reformulate it on the spot to form the hydrogen gas for the car.